Thank you so much. Hello, everyone. Today we're from Dr. Chin's group, and we're presenting our project on food recommendations with large language models. So my name is Myra.
My name's Vihan.
Sohan.
So a quick little introduction on the inspiration of our project is we wanted to look into a new area where large language models, one of the most advanced technologies today that is like growing rapidly, could be applied to. And we thought of food, which is a huge necessity and enjoyment of life. So we were looking at chatbots like ChatGPT and we see how they assist with several questions regarding to almost any topic. So we came up with our question, which was, do LLMs have the capability to give reliable and informative food-related recommendations? So this is a little bit of background research we did on this topic. First, we looked at a paper that talked about their own large language model in the food area, which was called RAGU, and it used restaurant data and ChatGPT's API to be a professional food recommender. It was quite successful with a success of 96% accuracy. And then we looked a little bit deeper on like large language models capabilities in other places. So there's this paper on ChatGPT's capabilities, and it analyzed specifically its capability to be an artificial general recommender, and looked at like the LLM's responses and how accurate and how considerate they were of users' preferences. We also looked at different methods that you can use to train large language models to analyze data. And there was one example where they kind of did snippets and like translated that into values of the user's prompt in order to like let the large language model actually understand what it was processing. And then some final two things we saw were a fairness and recommender systems. So we wanted to avoid bias, obviously, when giving food recommendations. So this paper gave some insight on how you can like review fairness in recommender systems and try to reduce any unfairness. And lastly, some enhanced context-aware recommendation, this last paper we saw, which was showcasing like how large language models can work with real-time data APIs to enhance the recommendation relevance. And it did achieve a 20% increase in recommendation accuracy.
So now we get into the methodology of our project. So as part of our methodology, we designed and curated a set of 18 prompts that we tested each of the three main LLMs in the market, including ChatGPT and Gemini and DeepSeek on. So how did we design these prompts? So we created 18 prompts and they were broken down into three categories. So typically when you're going, we considered on the user's behalf, like what do they usually look for when they go to a restaurant? So we came up with these three major breakdowns. The first is if they're looking for a specific dish and that the availability and quality of a certain dish will determine which restaurant they ultimately choose. So these could include items like pepperoni pizza, frosted lemonade, or a cup of hot tea. Second is if the user has a particular craving for a specific style or cuisine, which could include Indian food, Italian food, Ethiopian food, or any other cuisine that the user desires. And lastly is if the user is looking to celebrate a particular occasion, which could include a birthday, anniversary, or a team building event. And often that'll dictate the vibe or the atmosphere of the place that they want to go to. So that's the first dimension of our prompts. Going more specific, we get into four what we call gradable categories. So these are more specific user-defined criterion that we put into our prompts. So the first is atmosphere. So if the user specifies like a particular vibe or service that they want in their place, including whether it's a formal or a more casual vibe, whether it's dine in or fast food, or if it's simply quick or a quick service. So these encompass atmosphere. Second, we have convenience, which includes things that make their experience more quick. So this could include locations such as being 5 minutes of walking distance from my school or 10 minutes of drive from my house, or even parking availability around the area. Third, we have affordability, where the user makes specific price specifications. So this could include wanting to treat himself to a meal of between $10 to $20 for one person, or wanting to host a graduation party with 15 people for not more than $200. And lastly, we have accommodations, which could include both dietary or physical accommodations. So dietary restrictions could include needing food that's vegan or low in cholesterol, while physical restrictions could include needing accommodations for wheelchairs or hearing loss.
So putting it all together, we have a three-dimensional system that is used to create the prompt that we generate and then give to the LLM. So over here, you can see the first dimension, which is the type of prompt. So in this case, for example, for a user that would want frosted lemonade, the type of prompt would be wants a frosted lemonade. The first criteria, that would be the second dimension, would be that they want a quick service. That is their kind of personal preference as to how they receive this service. There's third criteria, or criteria two in this on this slide, is that the food cannot exceed $10, so they have a budget constraint. So in the end, the golden set question, what we called a golden set question was like the prompt, the golden type of prompt that we're asking the LLM would come out to be recommend a restaurant that has quick service where I can get a frosted lemonade for under $10. So for this, we designed a scoring rubric which totally accounted for 25 points, in which accuracy was 5 points. So does the restaurant exist? Is it close to the location? Is it more of a prerequisite? Or is it just like in our methodology, we wanted to highlight local restaurants just so that we could actually get a true feel for how detailed the LLM could go in the local context. So we gave 5 points to that. And then 20 points was adherence to the user's criterion. Because at the end of the day, if you have a food LLM service that doesn't actually give what the user wants, then there's no point to having the service. So we gave a very high emphasis to this criteria. So this would kind of look like if I ask for Indian cuisine, does it only give me Indian restaurants? Or does it actually give me something that in the budget that I requested, like in the last slide, it's at $10? So that's kind of the score rubric we made for 25 points. So the prompt table example that we have here is it's our real prompts, and this just gives you an idea of how we kind of separate the dimension, how we create it, and like just kind of how we sort it. So the question that we asked the LLM is, I want a formal place for my birthday that's 5 minutes away from Dublin Park. Now, the umbrella that this goes under, that I believe it was Bihan that was talking about, or Myra, um, is experience. So the user experience is like formal. They want a formal vibe. And the criterion that it goes to, the two buckets, is convenience and atmosphere. So 5 minutes walk would be the convenience part, and the atmosphere would be formal. So that those kind of combine and create this sort of prompt that we give to each LLM. And when they were created, we got 18 out of 25 for GPT, 17 out of 25 for DeepSeek, and Gemini gave 22 out of 25, likely due to its better mapping abilities and able to give a sense of direction, which, like I mentioned in the last slide, was heavily weighted as being like user something that the user wants 5 minutes away in Dublin Bar. You can see the same for these next two prompts as well, that like the criterion are they're pretty easy to spot in the prompt. So like atmosphere would be laid back, accommodations would be Tourette syndrome. For the third one, criterion would be convenience and affordability, and you can see that in the prompt as well. So here are some sample responses that we got just to kind of give you an idea of what our LLMs outputted. So for ChatGPT, we're able to see this very clear map right here with the location at the bottom. And that was kind of missing from Gemini, but it has the Google Maps like wrapping on it. So it kind of makes up for that in some way. But ChatGPT has its own kind of version of this, and to some users, this might be better. Also, it's able to highlight specific parts of our request, as in like reservations, budget, accessibility, and it's very clear that it understands to separate them, while Gemini and DeepSeek often will give us responses that are kind of condensed. So in terms of overall LLM performance, each prompt was 25 points, multiplied by 18 prompts, so 450 total points. And what we did to ensure that, sorry, that these results were actually accurate was that we conducted 2 rounds of testing 5 months apart. So our original round one testing was 5 months before the confirmation round. And each round consisted of prompting and scoring each LLM to all these 18 the exact same 18 prompts, but to account for updates or fixes or bug fixes, anything of that kind that was done from the LLM side. And what we saw in this, as you can see in this chart right here, to the right, is that Gemini and GPT saw really high improvements, likely due to the fact that these are constantly updated and fixed LLMs versus DeepSeek, which may not be as constantly updated and kind of changed.
And now we get a little bit more into the details. So we also wanted to evaluate the performance based on the broad categorizations that we talked about earlier, the cuisine specification, food and drink specification, and occasion specification. And as you can see, between round one and round two, there is significant improvement in every area for every LLM. And this is obviously attributed to like Soham said, a lot of fixes that have been done for the LLMs over the months that these rounds took place. And finally, like after our analysis of the results and looking at our framework, we wanted to do a little bit more in depth of a cross-dimensional comparison on the like gaps that each LLM had and any trends that we could see. So here's what it looks like overall. As you can see, like we kind of noted down like some specific core areas that we wanted to keep in mind, and we tried to evaluate them for each LLM. And we noticed a pattern, as you can see here, that is circled. So the main positive points were its accuracy and honesty with all LLMs, its adaptability to constraints, and its transparency about limits. Those were all pretty well done. However, we did see that there were four different gaps that we kind of want to discuss and think of solutions that could be um, done to improve the LLM's performance in those areas.
So now we look more in depth into each of these gaps. So the first and probably most important gap is poor locational awareness across the board for each of these three LLMs. So looking at an example from DeepSeek, we used a prompt that reads, I'm looking for an Ethiopian place with a formal vibe that can serve my five friends who are all using wheelchairs and have epilepsy. So this is a very nuanced prompt. But as you can see, the user does not specify a place, likely because he or she assumes that the LLM will, by default, take that into account. However, as we see, starting with the first recommendation, is that it recommends a place in Washington, D.C., whereas this prompt was taken from Fremont, California. So this is obviously a problem, and it makes the LLMs completely useless in that sense. So this is obviously an urgent gap that needs to be fixed, and possible solutions can be including an additional layer in GPT that takes the user's geolocation or current location and recommends places based on where they currently are, so that it doesn't give places that are completely inaccessible. Our second gap is the inconsistent response structure across different prompts. So on the screen, we have two examples. And the first example shows um, two restaurants that, rather than in an organized and more consumable format, puts the recommendations and about in a paragraph format, which is hard to read for the user, and it's difficult for he or she to see the specifications that she asked for in the prompt. Whereas in the second example, the restaurant recommendations are clearly organized by price and group offerings, accessibility, and cuisine, each of which were specified in the prompt. So this represents a inconsistency in response structure across the same LLM. And a possible solution to this is by performing one-shot learning on the LLM by giving it an example of how each response should be formatted to ensure a bit more consistently consumable and organized responses.
Okay, our next gap is handling edge cases. So there were a few prompts that we added that were sort of like almost impossible or a little bit more like a test to see if it's just giving like responses or if it's actually checking if it can be done. So here's an example of one of them that, and it did like take, so overall for the gap, it was a little bit hard for the LM to handle these edge cases. So in this example of one of the prompts, it asked to find a cup of cream and mushroom soup for under $5. And this is almost impossible if you're thinking only of like restaurants, especially like in California. So the LLM, which in this case was Gemini, it did try to respond. It did give like one location that definitely did have cream and mushroom soup for basically almost $5. But the other two responses were a little bit lacking. It also did not really say that this thing is like impossible, really. It just said it was a real challenge. So I feel like it should be a little bit more specific by saying like, oh, this is not possible, but the minimum I can do is this much. Because as you can see, like it gave a very generic response for the second option, which is just grocery stores. A little bit more in depth would have been wanted, like talking about which grocery stores that are nearby to the user specifically. Um, that could be done instead. And then the final option it gave was also like not within the $5 budget. It wasn't even accurate here where it said $8. So that kind of consistency is needed, especially when handling edge cases. So a possible solution that we identified for this was for the LLM to have like an initial rule for itself to clearly identify and explain the limitations in respect to these edge cases. It needs to screen all of its data first to see for like if it can actually find something before it just decides to just respond out of the blue. And the last gap that we have is user experience. This is obviously something really important for a food recommender LLM. The user would want to like be able to come back to this numerous times, so it has to overall be a good experience for them. So this is something that definitely could be improved upon. And there's things like it only gives one option sometimes when a user generally would probably want a couple options to choose out of, especially since there's so many places all over the Bay Area. And also sometimes they're really generic instructions when taking into account like accommodations. So here I highlighted one prompt, which was like talking about looking for a laid back place that serves chocolate brownies at night, and the accommodation was Tourette's syndrome. Now, the only answer it gave me was this place called Cafe 86, and it's only one place, even though I know there's like so many other places nearby that can serve chocolate brownies. And also for considerations, it only gave these two generic considerations, no matter what the accommodation was, which is calling ahead and timing when to go. It would have been a little bit more personal for the user had it been specific to what their accommodation needs, like having a little bit more research or background on what that would look like. So a possible solution that we said for this was this obviously requires a lot of specialized training for the LLM, so it can fit the role of a general recommender model a little bit better. And we would want to use like data from websites like Yelp and maybe like other things, so it would just be able to train in these aspects. So a little bit about on like what's next for our project. We started doing like this thing called we call it phase two, which is improving our testing methodology by using a combination of large language models to auto grade responses. It really would allow us to use more prompts and mitigate grading bias. Like we did have to like manually grade these by hand, and it was consistent like with each researcher doing in both round one and round two the same LLM, so there was not too much bias, but to eliminate all little aspects of bias, it would be better if we can improve our methodology to be a little bit more standardized. And then finally, our phase three after that would be actually like building a framework using an existing open source LLM that can outcompete like the current capabilities of ChatGPT, Gemini, and DeepSeek in the food recommendation category. So, thank you so much. And we want to give a special thanks and shout out to our advisor, Dr. Chin, for all her guidance and support. Does anyone have any questions?